Hello and welcome to the first video for section 5.1 of Math 127 at UNLV. 5.1 is on the unit circle. Now, despite the fact that this is the first section, the first part of the video series that we're doing, I can't stress enough how important it is that this is probably the most critical video that we're going to do all semester. So much of what we're going to do the remainder of the semester is based off of the unit circle and its measurements. So that's what we're going to spend quite a bit of time on this video and throughout the semester as well. So, first off, definition of what is the unit circle. So the unit circle is a circle with radius 1 centered at the origin. So what this means is, if we were to draw our XY coordinate system, and we had a circle that was centered at the origin, the radius at any point along this circle would have a value of 1. And going back to our standard form for the equation of a circle centered at the origin, that tells us that the equation for a unit circle is x squared plus y squared equals 1. The first day of class, I handed out this unit circle handout. If you weren't here, if you're watching the video, you're not part of my class, you didn't get it, you can see along the bottom here, embeddedmath.com. A little bit closer for you. If you go to embeddedmath.com, you can print off your own copy there. We're going to fill this in. These values are critical that you get them correct. So if you need to pause the video, if you need to rewind it, if you need to reference another website, please do, because it's of ultra importance, the values we put on here, because we're going to be using them throughout the entire semester. So let me redraw this diagram here that I gave you. So we have this unit circle, meaning that no matter which way we go, we're a distance of 1 unit away from the origin. So if I go directly along the x-axis, the coordinate at this point would be 1, 0. We've moved 1 unit out to the right, none up or down. Similarly, if I move to the left on the x-axis, I've come 1 unit to the left, which means this is going to be negative 1. And again, up or down 0, so the value is 0. So you'll want to go ahead and fill those in on your chart. If we move along the y-axis, if we go straight up and down, we've gone up 1 unit, but we haven't moved left or right. So the value here is going to be 0 and positive 1. And if we go straight down, again, we haven't moved left or right, we've just went down, so the value would be 0 and negative 1. On the unit circle, we're going to be dealing a lot with what's called radian measures. Up until this point, you've probably been using degrees your entire life when it comes to a circle. 180 degrees, 360 degrees, 90 degrees. Well, again, we're switching to radian measures. So what does that mean? Well, first off, this will always be our starting point, so let's call that 0. And you'll see on your little diagram you have, actually it's on the inside, so let me put it there. You have a line with degrees, so that's 0 degrees, and then another line which is our radian measure. And that's also 0 radians. And then there's 2 lines underneath. If we went an entire time around the circle, well, that's what? That's 360 degrees. But how many radians is it? What distance is it? If this was a sidewalk in a park, a circular sidewalk, and we started at 0 and we went around the entire circle and we got back to our starting point, how far have we walked? That's what radian measures talks about, the distance along the outside of the circle. Well, the distance around a circle is what? The circumference. So we're going to use the circumference formula. Circumference formula is what? It's the diameter times pi. Well, we know that because this is a unit circle, it has a radius of 1 in both directions. So the diameter would be what? Well, the diameter would be 2. And then again, pi. So that means the circumference, if we were to go the entire way around this circle, this has a radian measure of 2 pi. So 0 or 2 pi or 4 pi if we ran around twice, they all reference the same point, which is right here. What if we only went halfway around the circle? Well, it'd be half of 2 pi, which is just pi. So the radian measure over here at -1, 0 is pi. If we only went a quarter of the way, so if instead of this entire circumference, if we went 1/4 of the 2 pi, well, the 4 cancels with 2, and we get pi over 2. So the radian measure at the top here is pi over 2. And then lastly down here, the radian measure is 3 pi over 2. So go ahead, fill those values in, make sure you have those. I'm not going to worry about degrees right now. If you want to go in later and fill in degrees, that's okay, but we're just going to be focusing on the radian measures for this circle. Now, you can see on your diagram you have a bunch more lines. So I'm going to use different colors for those. If you want to use different colors as well, probably not the worst idea in the world, and you can keep it straight. So within quadrant 1, the upper right quadrant, we have these 3 additional lines on the diagram. Let's start with the blue line. So the blue line is halfway between 0 and pi over 2. So that means we're basically taking pi over 2 and dividing it in half, so multiplying by half, which means we have pi over 4. So the radian measure for this blue line is pi over 4. Outside the circle you have these parentheses, which are the coordinates for the radian measure pi over 4. These values I will give to you, it's square root of 2 over 2 and square root of 2 over 2. Let's move to the green line. So the green line, if we focused on just the upper half of this circle, the green line represents 1/3 of the way around. So 1/3 is the same as pi, the whole way around the top, divided by 3. So the green line represents the radian measure of pi over 3. Its coordinates are 1/2 and square root of 3 over 2. And then finally the red line, again if we just look at the top half, you can see that the red line is splitting pi over 3 and 0 roughly in half. So it's half of pi over 3, which would be pi over 6. So the red line represents the radian measure of pi over 6. And its coordinate values are square root of 3 over 2 and 1/2. If we want to reference this in terms of degrees, the pi over 6 is 30 degrees. The pi over 4 is 45 degrees. And the pi over 3 is 60 degrees. We'll learn later how to convert from radians to degrees or from degrees to radians. But if you want to fill in your sheet for now, those would be the values. Now, we know circles are symmetrical. So we could actually continue this red line over this way. We could continue the blue line down into quadrant 3. We could continue the green line down into quadrant 3. We can also fill in 2 and 4. So we said that the green line was pi over 3. It was 1/3 of the way. So this other portion of the green line, if we came this way, would be 2/3 of the way. So if we want, we can write that in. 2 pi over 3, or 2/3 pi. 2/3 of the way around to this point. Same with the blue. If the blue is 1/4, this would be 2/4. So this line here in quadrant 2 would be 3/4, or 3 pi over 4. And then the red line here, these all represent sixths. So 1, 2, 3, 4, 5. So this red line here would be 5 pi over 6, or 5/6 of the way over towards pi. If we want to keep going, if this is pi is 6 over 6, the next red line would be 7 pi over 6. The blue, this would be 4 over 4, so the next one would be 5 pi over 4. And then this green, well, pi, if we're talking about thirds, it'd be 3 over 3, so the next one would be 4 over 3, or 4 pi over 3. And then if we want to continue the spokes down into quadrant 4, if this is 4 pi over 3, this would be 5 pi over 3. The blue, if this is 5 pi over 4, this would be 6 pi over 4, so 7 pi over 4. And then lastly, this would be 11 pi over 6. So those are all of our radian measures. But what about our coordinate values? In quadrant 1, we know that the values x is always positive, y is always positive. In quadrant 2, our x value is negative, y is positive. In quadrant 3, they're both negative. And in quadrant 4, x is positive and y is negative. The reason I use these specific colors for the thirds or the fourths or the sixths is as long as we know the values in quadrant 1, we can figure out the rest based just on what quadrant they fall in, because they'll just have the same values, they'll just be plus or minus. So, let's do the green ones first. So if we go to 2 pi over 3, which is this line here, well, it has the same values as pi over 3, which is 1/2 and square root of 3 over 2. But because it's in quadrant 2, the x value is negative, which means 2 pi over 3 has the coordinate measurements negative 1/2 and square root of 3 over 2. Let's stick with the green, so we're talking about the same value. So if we go down here to 4 pi over 3, again, I know it's 1/2 and square root of 3 over 2, because that's what it is in quadrant 1 for the values of pi over 3. But because I'm down at quadrant 3, these both have to be negative. So the coordinate measurements for 4 pi over 3 are negative 1/2, negative square root of 3 over 2. And then lastly, 5 pi over 3, again, it's 1/2 and square root of 3 over 2. But in quadrant 4, x is positive, y is negative. So it's going to be 1/2 and negative square root of 3 over 2. Let's move to the blue. So we can see in quadrant 1, it's always square root of 2 over 2 for both x and y. So I can just go around here, put square root of 2 over 2 wherever I have my blue markings. And then I just have to get the sign right. So in quadrant 2, my x value is the one that's negative. So it's negative square root of 2, positive square root of 2 over 2. In quadrant 3, they're both negative. So it's negative square root of 2 over 2 and negative square root of 2 over 2. And in quadrant 4, x is positive but y is negative. So it's square root of 2 over 2 and negative square root of 2 over 2 for 7 pi over 4. And then lastly, my red values, the pi over 6's, is going to be square root of 3 over 2 and a half, square root of 3 over 2 and a half, square root of 3 over 2, 1/2. In quadrant 2, so 5 pi over 6, my x value is negative. Y is positive, so it's negative square root of 3 over 2, positive half. They're both negative in quadrant 3, so negative square root of 3 over 2, negative 1/2. And 11 pi over 6 in quadrant 4, my x value is positive. My y value is negative, so square root of 3 over 2 and negative 1/2. I know what you're saying. I'm never going to be able to memorize this whole thing. How am I supposed to know this for the entire rest of the semester? Like I said, the values are all similar as you move around. If it has 6 as a denominator, they all share the same coordinate values. So all you really need to worry about is knowing the values in quadrant 1. If you know that, then the rest you can figure out based on the sign. So that at least cuts down some of the memorization. But then you're asking, okay, well, how am I supposed to remember all these? Which order they go in? Where's the square root? Things like that. Well, let's just look at coordinate 1 and these values here. What's the first thing we notice about the denominator? They all have 2 in their denominator. So that saves us some of the work. We can just start by writing the values and put 2 in the denominator. So then the only thing is, what goes in the numerator? Well, here's a trick that one of my former students showed me that she learned on Pinterest. If I lay my hand over quadrant 1, what happens? Well, my thumb is the x-axis, my pinky is the y-axis, and my other 3 fingers, what happens? They fall on pi over 6, pi over 4, pi over 3. So if I want to know what's the value for pi over 6, it's along my index finger. If I move that finger back, what happens? I have 3 and 1. 3 and 1. And then all I have to do is take the square root of the numerator. So if I remember that the denominator always gets a 2, the numerator always gets a square root, I know if it's 3 or 1 based on this little trick here. So square root of 3 over 2, and then square root of 1. Well, square root of 1 is what? It's just 1. So we don't really need to write that in there, so it's just 1/2. What if I want pi over 4? So that would be the middle finger. If I move that back, I have 2 and 2. 2 and 2. And lastly, pi over 3, 1 and 3, 1 and 3. So that tells me the order of which one gets the 1, which one gets the 2, which one gets the 3, and then I know just to square root both of them. So there you have it, the unit circle, the radian measures, and the coordinate values that go along with it. That ends part 1 of section 5.1. I will see you guys in part 2.